The universe is vast, filled with stars, planets, and galaxies, each one a cosmic island. Just when we think we've seen it all, the cosmos surprises us. Recently, NASA's telescopes revealed a breathtaking new discovery: a distant, swirling city of stars. This cosmic whirlpool is more than a pretty picture. It's a story written in starlight, traveling billions of light years to reach us. Every speck of its light carries secrets about the universe's past. By studying it, we unlock clues about the building blocks and forces that shape everything we see. This galaxy is a time machine, letting us glimpse an earlier chapter in the universe's story. Its discovery sparks excitement and new questions among scientists everywhere. Imagine, beyond the stars we see at night, there are countless galaxies, each with billions of stars. This newfound whirlpool is one of those distant islands, a place of beauty and power where new stars are born. For astronomers, finding a galaxy like this is like discovering a new species in an unexplored jungle. This particular whirlpool challenges what we thought we knew about how galaxies form and grow so quickly. It's a cosmic rebel, a giant that defies our old theories. Science is a journey of discovery, where every answer leads to even more thrilling questions about our place in the cosmos. So, what is a cosmic whirlpool? It's the poetic name for a spiral galaxy. Picture stirring milk into tea. A swirling pattern forms. A spiral galaxy is like that, but on a cosmic scale. It's a vast, spinning collection of stars, gas, and dust, all held together by gravity. Our own Milky Way is a spiral galaxy. We live on one of its arms. At the center is a bright bulge packed with old stars, orbiting a supermassive black hole. Stretching out are the spiral arms, cosmic nurseries filled with young, hot stars and glowing clouds where new stars are born. The arms aren't solid, they're waves of density moving through the galaxy's disk. Dark lanes of dust trace these arms, tiny particles, the raw material for future stars and planets. Without this dust, there would be no new stars, no planets, and maybe no life. So, these dark lanes are reservoirs of potential, holding the ingredients for cosmic creation. A cosmic whirlpool is a living city of stars, always changing, shaped by the laws of physics. Gravity pulls everything together, while starlight pushes things apart, creating a delicate balance. When we look at a spiral galaxy, we see a process billions of years in the making. It's a snapshot of the universe in action, a grand dance of matter and energy. Spiral galaxies remind us of the elegant, complex systems that govern our universe. How do we find these distant whirlpools? We can't travel to them, so we build telescopes, our eyes on the universe. Telescopes like Hubble and the James Webb Space Telescope collect ancient light that's traveled for billions of years. Hubble orbits above Earth, capturing stunning images in visible and ultraviolet light. It revealed the universe's beauty and changed our perception forever. The James Webb Space Telescope, or JWST, sees in infrared, peering through cosmic dust to reveal hidden galaxies. Infrared lets Webb see even more distant, ancient galaxies than Hubble. Together, these telescopes work as a team. Hubble shows us structure, Webb reveals hidden secrets. By combining their data, scientists build a complete picture of galaxies, their composition, age, and history. These machines are our way of touching the stars without leaving home. Let's meet one of these amazing discoveries, the Big Wheel Galaxy. Astronomers found this giant spiral galaxy 11.7 billion light-years away. The light we see from it began its journey before Earth even existed. The Big Wheel was discovered by accident, photobombing a James Webb image. Its size and well-formed spiral structure shocked astronomers. It's about 5 times more massive than the Milky Way, with a bright reddish center and huge spiral arms. In the early universe, we expected small, chaotic galaxies, not grand giants like the Big Wheel. Its existence suggests galaxy building started earlier and faster than we thought. The Big Wheel is a beautiful anomaly, forcing scientists to rethink their models. It's a cosmic puzzle that will keep astronomers busy for years. One observation can change our entire understanding of the universe. The Big Wheel is a testament to the surprises that await us in the deep. The Big Wheel's location is as fascinating as the galaxy itself. It lives in a crowded cosmic neighborhood, an overdense region, like a city center at rush hour. There are over 10 times more galaxies here than average for that era. This crowdedness may explain why the Big Wheel grew so big, so fast. Galaxies in these regions interact, collide, and merge, often destroying spiral arms. Yet, the big wheel has survived, keeping its elegant structure. Scientists think it may have grown by gently feeding on smaller galaxies and streams of gas rather than violent collisions. Studying its environment helps us understand how the universe is structured. Even in the early cosmos, massive clusters were forming, the seeds of today's superclusters. The Big Wheel's neighborhood is a unique lab for studying galaxy evolution in extreme environments. It's a story about a galaxy and the cosmic ecosystem it calls home. In astronomy, looking far away means looking back in time. Light takes time to travel. Even from our sun, it takes 8 minutes to reach us. The light from the Big Wheel traveled 11.7 billion years to our telescopes. We're seeing it as it was when the universe was young. Earth and the sun didn't even exist. By studying this ancient light, we open a window into a lost epoch. We can analyze what the galaxy is made of, how fast its stars move, and how many new stars it was forming. This light carries the chemical fingerprints of elements forged in stars. By measuring these, scientists learn how many generations of stars lived and died in the Big Wheel. Telescopes like Hubble and Webb let us piece together the universe's history, frame by frame. The Big Wheel is a critical snapshot in our cosmic photo album. The spiral arms of a galaxy like the Big Wheel are more than beautiful. They're dynamic engines of creation. These arms are waves of compression, triggering new stars to be born. That's why they glow with the blue light of young massive stars, stellar nurseries in action. By studying their light, astronomers learn how fast the galaxy is building itself. The presence of active, well-defined arms in such an ancient galaxy is extraordinary. The arms are also rich in dust, crucial for forming planets. Observing this dust tells us if planet formation was possible even in the early universe. The clear, preserved arms suggest the Big Wheel grew peacefully, avoiding major collisions. Its arms are a sign of a gentle past, a quiet giant growing gracefully in a chaotic universe. The spiral arms hold clues to the galaxy's history and the universe's evolution. Why study a faint smudge billions of light years away? Because we're explorers at heart. Space is our final frontier, and exploring it is the grandest adventure. Studying galaxies like the Big Wheel helps us understand our own origins and the fate of the Milky Way. Every galaxy we study adds a piece to the puzzle of our existence. The pursuit of knowledge drives technological innovation. Building telescopes leads to new technologies that benefit life on Earth. Techniques from astronomy have improved medical imaging and even our phone cameras. Exploring space truly makes life better here. Ultimately, it inspires us, lifting our eyes from daily concerns and connecting us to something vast. Seeing galaxies with billions of stars reminds us of our place in the cosmos. This perspective fosters unity and a sense of responsibility for our planet. The quest for knowledge enriches the human spirit. The discovery of the Big Wheel galaxy isn't an end, it's a beginning. It opens a new landscape of questions. How many more giants are out there? Are they rare or common? Each discovery brings new mysteries to solve. Astronomers will use Webb to hunt for more massive galaxies, building a census of the early universe. By studying many giants, we'll learn what conditions allowed them to form. Science moves from single surprises to broader understanding. Maybe we'll find the first stars, or a planet with signs of life, or finally understand dark matter and dark energy. The universe is full of secrets, and we've only scratched the surface. The journey of discovery is endless, connecting us to the stars and to each other. The cosmos is the ultimate storybook, and we're just beginning to read its pages.